All right, we're going. So here are the solutions. We're going to write this calculus friendly. Let me do this. Let me rearrange some stuff here. My head isn't on a swivel. All right, I think we're good now. Hey, that's calculus friendly. Then the derivative, you take the exponent, multiply it in front. Copy. Subtract 1 to the exponent. That's 1. I'm not going to write down 1. And then the derivative rule for cosine is negative sine. Copy. And then the hook for 4x is 4. We barely fit it in there. Second, write down what you're doing. This is a derivative. The derivative rule for tangent is secant squared. Copy. And then the hook, the derivative of ln x. The derivative rule for arcsine, draw a fraction line. Square root 1 minus, square it. Then the derivative of x minus 2, and it's done. This one's the product rule. The first times the derivative of the second plus the second times the derivative of the first. And you could definitely see this answer like this or like this, changing the order. The quotient rule. The bottom times the derivative of the top, which is negative cosecant cotangent. Subtract the bottom times the derivative. Wait a second. The bottom times the top minus the top times the derivative of the bottom. It's still going to be this. So that's the top times the derivative of the bottom, and then the bottom squared. That could also be e to the 2x. Derivative. 1 plus 3 to the x squared, and then the derivative of 3 to the x is copy with ln 3. The derivative of cotangent, negative cosecant squared, and then there's a hook of 2. This again is the product rule. So that is the first times the derivative of the second. That has a hook of 3 plus the second times the derivative of the first. The derivative of arc cosine, square root 1 minus 5x squared, and then the derivative of 5x is 5, but it needs to be negative for the rule. The derivative of secant, that is secant tangent, and there's a hook of 2 at the end, because the derivative of 2x plus 3 is 2. Write this one friendly. So we're going to start with 3 times 1 in front and then copy. Subtract 1 to the exponent. The derivative of cotangent is negative cosecant. The derivative of e to the 3x is e to the 3x, and the derivative of 3x is 3. So there's a bunch of hooks there at the end. They're all multiplying. They would all go beside each other. Implicit. The derivative of cosine is negative sine y with a hook of y prime. The derivative of sine is cosine. And the derivative of y squared with a hook of y prime. All right. You can do either way. To make everything positive, I can add sine y prime, factor out a y prime, and then the last step is to divide. So the answer is cosine x over 2y plus sine y. Now, if you add the answer negative, 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 it's still the same answer. Good. All right, so that's practicing derivatives. Turn the page. Can you practice integration by memory? This one's going to be a little more challenging. So where does the hook come from? So the derivative of, we're focused in here, the derivative of 4x minus 1, so the hook should have been 4. It was a 3, and it became a 4, so the answer is going to start with 3 over 4. The hook is not part of the final answer. The integration rule for sine is negative cosine, and then plus c. I know my camera keeps going blurry, I'm sorry. All right, integrate. This looks like arctangent. If it's arctangent, a is the square root of 9, u is the square root of x squared, and then u prime is the derivative of x. So this should be a 1. It was a 3, and it became a 1. So our answer is going to start with 3, and then the rule. So the rule for arctangent is 1 over a. A is 3. Arctangent, and then u over a. And then plus c. And you know 3 and 1/3, you could easily see this answer is just that and be able to match it if it was multiple choice. All right. The hook here is 1, so it was a 2. So the answer is going to start with 2 over 1, or 2. And the rule for cosine is sine, not negative sine when you integrate. And it goes from 0 to pi over 3. And then, could you simplify this? So the value of sine at pi over 3, what's the y coordinate at pi over 3? And it's root 3 over 2. What's the y coordinate at the angle 0? And the answer is 0. So this answer is just root 3. The 2's cross out. All right, what does this one look like? Looks like arctangent. A is the square root of 4. U is the square root of x squared. And then the derivative of u is the derivative of x, which is 1. Notice the hook should be 1. So it was a 2 and it became a 1. So the answer is going to start with 2, and then 1 over a, and then arctangent, and then u over a, and then plus c. And again, 2 times a half, you could easily see the answer is just arctangent x over 2 plus c. Now the next one looks like arctangent, but it's not. And so when you take the derivative of the bottom, the derivative of x squared plus 4 is 2x. You know another way to tell, if you want to listen, is the degree on top is only 1 less than the degree on the bottom. That's a logarithm. The degree on top is 2 less. Think of this as x to the 0, if you want. In that when you have it 2 less on top, then that's arctangent. 1 less on top, that's a logarithm. And the hook is right, it's there. So the answer is ln x squared plus 4 with the candy bars. Believe it or not, for this one, you don't even need the candy bars because all values would be positive no matter what number you plug in here. but it's not wrong if you have the bars. How about here? Well, the degrees match. Now what? And the answer is we need to divide. So we're going to do long division. It's not very long. X squared divided by x squared, that's 1. And then the remainder. So we're going to integrate 1 and 4 over x squared plus 4. So I'm going to do that here. The square root of 4 is 2. The square root of x squared is x, and the derivative of that is 1. So it's a 1. It should be a 4. So when I integrate it, it's going to look like this. So 1 is just x. And then my answer is going to start with 4, 1 over a, arctan, and then u over a, plus c. So this 4, if you think of the hook, it should be 1. So what was it? 4 over what it became 1. So the 4 is the hook in front, the adjustment. The 1/2 is part of the formula for arctangent, and then x over 2 plus c. We know that 4 times a half, you could also write that as just 2. Plus c. All right, what are we going to do here? So we're going to complete the square so we can do arctangent. So to complete the square, you take the b value, divide by 2, and square it. So we're taking 2, and we're dividing by 2 and squaring. That gives me a number to add and subtract to complete the square. We're going to add 1 and subtract 1. Now, if I factor this, two numbers that multiply to 1 and add to 2 is 1 and 1, so that's 1 squared. And then negative 1 plus 5, that's 4. And now we're ready to write down a, u, and u prime to be able to integrate this. So a, the square root of 4, u, the square root of x plus 1 squared, they just cross out, x plus 1, and the derivative of x plus 1 is 1. So this is a 1, so it was a 4 and it became a 1, so the answer is going to start with 4, and then u over a, and then arctangent u over a, plus c. And again, you could go 4 times a half and get 2 in front. All right? The integration rule for tangent, not secant squared. That's derivative. How do you integrate it? And so, first of all, the hook. So the hook here is 2, so we need, it was a 1, so it became a 2, so we need a 1/2. Now the rule is negative ln, and it's cosine 2x minus 1 plus c. All right, the hook here is 4. So it was a 1 and became a 4. And the rule for secant tangent is just secant, 4x plus c. All right, this looks like arcsine. So a is the square root of 1. U is the square root of x squared, and u prime is 1. So this should be a 1. It was a 3, and it became a 1, so our answer is going to start with 3. For arcsine, there isn't a fraction. It goes right to arcsine, and then u over a. So x over 1 is just x, and then plus c. All right, 2 left. This is a unit circle one again. The hook should be 1/2. It was a 1, and it became 1/2. So 1 over 1/2 means the answer is going to start with 2. So 1 divided by 1/2, that's 2. And then what's the rule for tangent? It's negative ln cosine, in this case x over 2, and then from 0 to pi over 2. So plug in pi over 2 to begin with. So pi over 2 divided by 2 is pi over 4. When you subtract a negative, it'll end up being plus 2 ln cosine 0. Now we're going to go as far as we can with this. The x-coordinate at pi over 4 is root 2 over 2. Cosine 0 is 1. And then ln 1 is 0. So our answer is just negative 2 ln root 2 over 2. Otherwise, I'd need a calculator to be able to do anything else other than that. All right, last one. It kind of feels like it's arc sine, but the degree here, like if I square root 2x, and so it's not going to match when you try it. So this one is calculus friendly. If this said 2x squared or 4x squared, like it needed to be x squared, then when you square root and take the derivative, it's going to match. But this one doesn't. This is calculus friendly. So we're going to write 1 minus 2x to the exponent negative a half. And then the hook is negative 2. It was a 4, became a negative 2, so divide and you get negative 2. Notice when you multiply them, it equals 4. This hook goes away, so the answer is going to start with negative 2. And we go 1 minus 2x, add 1 to the exponent, divide by that exponent. You know dividing means the same as multiplying by the reciprocal. So the reciprocal of 1/2 is 2. And negative 2 times 2, that's where negative 4 comes in. You could even be really fancy and write it like this, and then plus c. Plus c. Pretty fancy, right? Turn the page. Do I have to? No. On the exam on Monday, you could just do that, and it'd be the right answer. Plus c. All right. Limits. Try it first. So I'm going to evaluate what's the value at tangent at 0, and the answer is 0. So we can separate this into 2 limit questions and then recognize it is indeterminate. And then what do you do when it's indeterminate? I know it's blurry. So if you plug in 0, you get the answer 0. If you plug in 0 again, you get the answer 0 again. It's indeterminate. This is L'Hopital's rule. Going to the hospital. The derivative of tangent is secant squared, and the derivative of sine is cosine. And then we're going to plug in 0 again. For these, we actually do have a value. So let's start here. The value of cosine at 0 is 1. Secant at the same angle is just the reciprocal. Well, the reciprocal of 1 is 1, and then you square it. Well, 1 squared still is 1. So this ends up being 1 divided by 1, or equaling to 1. Let's try this again. Let's write this as 2 limits. So 1 for the numerator. So pi over 2. What's the value of cosine at pi over 2? And the answer is 0. The second one at pi over 2 for sine, pi over 2 minus pi over 2. Well, pi over 2 minus pi over 2 is 0, and the value of sine at 0 is 0. So this is L'Hopital's rule. Take the derivative. So the derivative in the numerator, the derivative of cosine is negative sine. The derivative of sine is cosine. There's no chain or hook here at the end. The derivative of x minus pi over 2 is just 1, so we don't need to write it. And then again, I'm going to plug in pi over 2. So we have negative sine pi over 2. We have cosine pi over 2 minus pi over 2. So I'm just going to write down 0. So the value of sine at pi over 2, the y-coordinate at the top of the unit circle, is 1. But it's negative 1 when you put it together. The value of cosine at 0, the x-coordinate at 0 is also 1. So altogether this answer is negative 1 when we put it together. Another limit question. No trigonometry. How boring. This is an end behavior question, which means I need to know the power terms. So I'm going to write down the limit as x approaches infinity. What's the power term in the numerator? Be careful. It's 4x squared. The denominator is 8x squared. Divide the x squares, and the answer is 1/2. Oh, back to trigonometry. Thank goodness. All right, what's the value of tangent at pi? The answer is 0. What's the value of cosine at pi? And the answer is -1. This is not indeterminate. It is 0 divided by -1, which equals 0. So don't assume it's 0 over 0. All right, next, you need to try this. And if you're tired, press pause, come back to it. Find the average value. What kind of question is average value? And the answer is it's an integration question. And I'm going to integrate from 0 to pi over 2. I'm integrating cosine. And then I divide by the difference of the bounds. So there's the setup for average value. So can you integrate cosine? That's negative sine from 0 to pi over 2. And then we take that answer and divide it by pi over 2. So just so you know, whenever you divide by a fraction, you multiply times the reciprocal. So we can just write 2 over pi and not have a fraction. And then we're going to plug in pi over 2. When you subtract a negative, so it should be subtract, but it's negative. So a negative and negative adding. And then the value of sine at 0, and then finish it. So what is the average value? So the value of sine at pi over 2 is 1, and the value of sine at 0 is 0. So if we put this together, -1 plus 0 is -1, and multiply, the answer is -2 over pi is the average value of sine from 0 to pi over 2. Oh, sorry, for cosine from 0 to pi over 2. Wait a second. One mistake. Integrating cosine is positive sine. I knew the value was positive, so that's why I was like double checking in my brain. This is all positive, which means this should be positive. That was the only mistake. So the derivative of cosine is negative sine. The integration of cosine is positive sine. So even I, right, can make a mistake and think twice. When I thought of what it was asking, what the average y value is from 0 to pi over 2, I knew the answer was positive because the x coordinates are all, anyways, positive there. So this should have been a positive value, but everything else was right. Positive. All right, find the equation of a tangent line. We got this? What does x equal? That's 1. What does y equal? That's pi over 2. And the slope. Well, I need to take the derivative of y first. So the derivative of arc sine, fraction, square root 1 minus x squared over 1. And then what are we plugging in for the x value? Uh-oh, we're in trouble here. So, but I'm going to tell you what it is, because we can still answer it. So the slope here is undefined. So when I plug in 1 and solve it, the answer is not 0. It's not anything. It's 1 divided. It's undefined, which means there is no, that means that there's a vertical tangent line. And there's your answer. So there is an answer. So if it's undefined, that means it's a vertical line, and it's just x equals 1 is the answer for the tangent there. Almost there. Can you solve the Diffie-Q? Again, if you're tired, press pause, try it again later so you have the energy. What do we do? So first, I'm going to write and divide by 1, first of all, dy by dx. So let's do that first. So 1 plus 2x squared dy by dx, and then 4xy. And then we're going to separate the variables. So to get the y's on one side, I'm going to divide by y. So instead of multiplying times y, not the 4, I'm going to let it go. So the 4 is going to stay there. So I'm just going to divide by y. And then on the other side, I have 4x, and I'm going to divide by 1 plus 2x squared. And that's dx. I know it takes a moment. So just take a moment to see what I did. Divide by 1 plus 2x squared. Divide only by y. And then multiply by dx. Can you rearrange it so the y's are on one side and the x's on the other? We're going to integrate this. That's ln. This is also a logarithm. The derivative of the bottom actually matches the top, so it's ln 1 plus 2x squared plus c. Almost wrote down dx. We can cross these out and recognize that 1 plus 2x squared is always a positive value. And then, what do we got? Do we have a point? No. So there it is. I didn't give you a point. How about if I give you a point up here? Just for fun. So if I give you a point on there like 1, 5, I'll add that. So next time I use it, I'll have a point. How would you go from that step to this step? So you would plug in 1 for x, and y would be 5. And then you would solve for c. So 2 times 1 squared plus 1, that's 3. Subtract 3, and then you have your answer. So if I put it all together and go back to here, it'd be y equals, and it'd be 1 plus 2, that's 3, and you'd have your answer. Really, this is what I should have done. Let me think here. That when I had the plus c, this is better to do it this way, because that plus c, that kind of bothered me when I, so I'm not going to do it this way, but I still can use that point. All right, so e and ln, they do cross out, and then I can this plus or minus e to the c, I can redefine that constant and just call it c2. That's 1 plus, right? One plus. It might end up being the same thing. And then when I plug in 5 and 1, it'll be a little different, because it'll be 5/3 instead, which is more accurate, which is the right way to do it. So this answer should have been y equals 5/3 1 plus 2x squared. And you know what happens if something's more complicated? Maybe you need to do it again. Like take out a blank piece of paper and write it down again and go through steps until they feel like they make more sense to you. All right, 2 left. The acceleration of a particle is this, sine t. It says the initial position of the particle is pi, and the particle is at rest initially. So let's start first. How would I find velocity? Is I would integrate the acceleration. So the acceleration is sine. So if I integrate, that will give me velocity. So the integration of sine is negative cosine. And then it tells me the particle is at rest originally, which means if I plug in 0, the answer has to be 0. That's what it means. If it's at rest, the velocity is 0. Cosine at 0 is negative 1. So if I add 1, c is equal to that. And then I come back here and say, okay, now I know the velocity. It's negative cosine t plus 1. So again, follow what I did. Integrate sine, negative cosine plus c. If it's initially at rest, that means when you plug in 0 for t, 0 is the velocity, and then solve it. The value of cosine at 0 is 1. So it's negative 1, add 1, and that's what c equals, and I have it. Oh man, it says find the acceleration. That's not what I meant. So let me go back and change this to the word position. Find the position of the particle. Typo. It's going to be okay. So we're going to integrate the velocity to find position. So the integration of negative cosine, well, the integration of cosine is sine, so negative would just make it negative sine. And then the integration of 1 is 1t, and then plus c. And then it says the initial position of the particle is pi. So that means when I plug in 0 for t, the answer is pi. So the value of sine at 0 is 0 plus 0. So all that's left here is that c is equal to pi. So if I put it all together, the position of the particle is negative sine t plus pi. And there's the position equation of the particle. And I'm going to go back and change that in my document so it says position. Sorry about that. All right, last one. Volume. Find the volume when revolving this graph around the x-axis. So if I think of the graph of cosine, it starts at 1, and then at pi over 2, and it kind of looks like this, and then keeps going, that it's this right here, from 0 to pi over 2, and we're going to revolve that around the x-axis. So we're going to go pi r squared from 0 to pi over 2, and recognize that there's no space here at all. So there's only one circle, one disk, no washer. And then you're going to go top, the curve, top, subtract bottom. So that's cosine x, subtract 0, and that's squared. Now, we're going to get stuck here, so we're going to leave it right here. And this is the reason we're going to get stuck. That's the setup to find the volume, but we don't have a rule for cosine squared that then would help me integrate this. So this right now would be a calculator question where we type it in our calculator, but we're going to let it go. So that's now the setup of that. All right, so you've gone through the review packet. I'm proud of you. I need you to study your trig rules and go over. You can even go over the assignment questions, things that you need to practice, and then on Monday is your exam. All right. Mr. G Math over and out. All the best. You guys got this.